So the midterm, or I guess the quiz, quite a few students missed the quiz date when you were supposed to write it for whatever reason. And they still haven't written it. So I can't actually tell you anything about your quiz until they've written the test, which is not going to happen until probably Friday. So you have to wait a bit to get your quiz results back. There is one thing I can say. There was something strange that a lot of people wrote. Well, not a lot. Some. If you've got a method, public, doesn't matter if it's static or not. Static void f, and then int. Sorry, if you're over there to the right, I know you can't read this. So you got a method that takes in an int as its parameter. That's always an int, right, in Java, right? Because, I mean, the parameter says it's an int, right? So it has to be an int, right? If you try to call this method with something that's not an int, the compiler will complain and the program won't compile. So there's no point in writing if n is not an int, right? That doesn't make any sense in Java. Might make sense in Python, because Python is dynamically typed, right? But you never check what the type is in a Java program. The type's here. So this doesn't make any sense. So if you write something like if n is not an int, or if n is a double, or n is an int, or n is a whatever, some type of numeric type, do something, that doesn't make any sense in Java. You never do that in Java. If you find yourself having to write code like that in Java, you've done something wrong, right? So never try to do something like this, right? And that's basically the only thing I can say regarding the quiz, right? Otherwise, so you should get your quiz results back, I'm guessing next Monday, okay? Oh wait, picking up where we left off. So we were talking about implementing methods in a class, so non-static methods in a class. And towards the end of the last lecture, we were talking about methods that belong to all classes, right? So there's this class called big O object, right? So java.lang.big O object. And it turns out the way the Java language is designed, all classes are what are called subclasses of big O object. So we'll talk more about subclasses in a couple of weeks, right? But what you need to know for now is that if everything is a subclass of big O object, right? So if every class is a subclass of big O object, and then what that means in Java is that every class has the methods that are defined, in big O object. Right, now it turns out there's 11 of these methods. I think 11. I haven't checked in the most recent version of Java. It's probably 11. There's no way they could add anything and not cause problems. So there are 3 methods that are going to be important to us in this course. Right? So there's a toString method, there's an equals method, and there's a hashcode method. Right? And so that's why when you're comparing two objects for equality, you can always write x dot equals y, and that always works. It's because every object, right, has a method called equals. Every object has a method called toString, and every object has a method called hashcode. Now toString is useful because it lets you produce a string representation of an object, right? So if you're debugging your program and you want to print the value of some object, then it would be nice if you got something that was readable, right? And so for a point, you might want to print out its x and y coordinates, right? So you might want to generate a string that looks like that. Right? So a string that looks like something a mathematician would write. That doesn't have to be the string you generate. You can generate whatever string you want, right? You can generate a string that says x equals -1, y equals 1.5, or something else, right? Square brackets, you can use braces, whatever you like. Right? Okay, so in our point2 class, we can create our own toString method. We're actually not creating our toString method. We're going to replace the one that we got from object, right? Because if you try to use the one from object, you get some gibberish, right? It doesn't mean anything to a human, the toString method that object provides. So you can replace the one that you get from object. When you replace the one that you get from object, the method header has to be exactly the same as what's in object. Right? So if you actually go look at the documentation for the object class, you'll see that the method toString is always public. It always returns a string. Its name is always toString, and it always has no parameters. So as long as you put in a method that has exactly that header, you will end up replacing the version of toString that you get from object. Right? Now, how do you generate the string representation of a point? Well, I need a round bracket. Right? Then I want the x coordinate. Then I want a comma and a space. Then I want the y coordinate, and then I want the closing round bracket. Right? And that's it. So you just make a string that's equal to the string that you want to produce for a point. Okay, now what's this funny @ override? Okay, so when you decide you want to replace a method that you got from another class, you can use the you can use this tag called @override. You don't have to use this tag, but you can. Right? So if you use that tag, the compiler will actually check, is there some method public string toString that comes from a parent class of the class that you're in. Right? So in this case, the compiler will check, is there a method called toString that returns a string and is public in the class object? If there isn't, the compiler will tell you this is not an override of an existing method. Right? So when you replace a method that you inherit from another class, that's called overriding the method. Right? If this method does exist in this case, the object class, and then the @override tag does nothing. Right? So if you spell something wrong here, right, the compiler will tell you that there's something wrong with what you've done. Right? So this tag here is optional. You don't have to put it in. Right? But if you put it in, the compiler will do some safety checks for you. Okay, now that we've got our toString method, how do you use it? Well, you can write something like this. Right? So I can make a point. Right? I can change its coordinates to something other than 0, 0. And then I can print the point. Right? So you just use system.out.print p toString. And if you run that program, so there it is right there, you actually get -1 and 1.5. Right? Now you actually don't have to write toString. Right? So you can just write the name of an object reference. The print line method is implemented in such a way that it automatically calls toString for you on that object p. Right? So this works just fine as well. Right? So you don't have to write toString after everything if you want it if you want to print it. Right? Just write the name of the variable and everything will happen. toString gets called for you automatically. Right? Okay, so that's how you replace the toString method in a class. Right? And you can replace the toString method in whatever class you create. It's often very useful because it helps you when you're debugging your programs. Right? You can print the state of an object and you can see everything that's going on inside the object. Okay, now what about our counter class? So in the counter class, so far all we have is a constructor that sets the value of the counter to 0. Right? What else would you like to do with a counter? Well, I'd like to know what is the current count. Right? So I'd like a method that returns the current value of a counter. Right? The counter is supposed to count up in increments of 1, so it makes sense if we have a method that counts up by 1. Right? So we want a method that advances the counter by 1. Right? And of course, as we've seen, it would be nice if there was a toString method for the counter class as well. Right? Now these methods are all straightforward. Right? So remember what our counter class looks like. It's got a private int, right, that stores the value of a counter object. Right? Our constructor sets the value of the counter to 0. Here we've just added a method called value that returns the current count or the current value of the counter. Right? What's the current value of the counter? Well, it's just stored in the variable called value. Right? So you just return this dot value. Okay, how do you advance the counter by 1? So you have to remember what advance does. Right? So advance increments the value of the counter up by 1. Right? If the method is called when the current value of the counter is equal to integer max value, then the value of the counter gets set to 0. So in other words, this particular class wraps its count back around to 0. Right? So it's like the odometer on your car. If any of you have actually seen an odometer on your car. Right? If you wind the odometer past the maximum mileage, it goes back to 0. It used to be the case a long time ago, you could take a car, you could run it in reverse, and the odometer would go backwards. Right? And then you could sell the car telling people that your car only has like 10,000 miles on it instead of the 150 million miles that it really has. You can no longer do that on you haven't been able to do that in a long time. Right? So, but that used to be, you used to be able to do that with the old mechanical odometers on cars. All right, so how do you implement this method? So obviously you have to check, is the value of the counter equal to integer max value? Or not equal to integer max value in this case, right? So if the value is not integer max value, I can just add 1, right? Otherwise, we wrap the value back around to 0, right? Now, if you don't have this if statement in, right, and the value of your counter happens to be integer max value, right, when you add 1 to it, it goes back around to integer min value, right, some very large negative value, which is not what you want in this case. Right? There's something else there's another very common mistake that is often made by new Java programmers. Often what a programmer will do is they'll check, is this value greater than integer max value, right? But that doesn't make sense either, right? This value is an int, right? There is no way for an int to be greater than the largest int value, right? So if you ever see yourself writing something like, is this int bigger than integer max value, you have to say to yourself, this doesn't make any sense, right? It'll never be true. Right? Similarly, an integer value can never be less than integer min value. Right? So you're either always checking for not equal to or equal to. All right, now what about toString? Well, toString, I need to print out the value. So when you implement toString, you have to decide what is exactly that you want to tell people about the state of your object. Right? So in this case, it makes sense to tell people what the actual count of the object is. Right? And so again, you can print this out. You can generate a string that shows this information any way you want to. Right? You can say counter has the value, or you can just print out the value or something like that. Right? Now, you probably don't want to print out just the value because it's just going to look like an integer value. Right? You probably don't want to put it in square brackets or round brackets or something like that because it's going to look like something else. Right? So in this case, I'm just going to slap the string count : in front of it and print out the value and add the value to the end. Right? But again, the way you choose to generate the string for your class, it's up to you. Right? Of course, you're going to document it up here, and I'll show you how to document your class in the next lecture. Yes? Okay, so the keyword this. So inside of a method, right? So inside of a method, the keyword this refers to the object that was used to call the method, right? So what does that mean? So somewhere I need a counter object, right? Because that's a non-static method. Right? So somewhere I have a counter C equals blah, right? So new blah, 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 right? Now that I've got this counter object, I can call toString on it if I want to, right? So string S equals C toString. Right? So I use a counter object to call a non-static method. Right? So inside toString, right, the keyword this, right, is equal to the object that's used to call the method. Right? Inside a constructor, the keyword this is equal to the object that's currently being initialized. Okay? Yeah.
So if there was a static method
Yep.
in a class
Yep.
for an object,
Yep.
Would it be used by other methods within that class only?
So that's a good question. So if you have a static method, so that's not a static method, but if you have a static method, there is no this in the static method. So that's number one, right? Because you don't use an object to call the static method, right? So you can call a static method from anywhere you want as long as it's public, right? So you don't need an object to call the static method. And you shouldn't use an object to call a static method. All right. Any other questions? Okay. The stopwatch class is a little more sophisticated. So remember the stopwatch, we're implementing this class that basically tries to emulate a physical stopwatch, right? So there's a start button, there's a stop button. So when you press the start button, the watch starts running, right? You can look at the watch when the watch is running, and you can see how much time has elapsed. Right? If you press the stop button, then the watch stops running, and it tells you how much time was elapsed between the start and stop time. Right? So I want a method that lets the user start the watch. Right? I want a method that lets the user stop the watch. Right? And I want a method that lets the user find out how much time has elapsed since the start button was pressed. Right? So if the watch is running, right, then the elapsed time is the time from when the watch was started till now, right, when the method was called. If the watch is not running, right, then how much time is on the face of the stopwatch? Well, it's the amount of time that passed between pressing start and stop. Right? So there's going to be an if statement inside of this method here. All right, so remember how our stopwatch class is implemented. It's got these fields called raw start time and raw stop time. Right? Those times come from this method nano time, right, which I'll show you in a second. Right? Okay, so start the watch. Right? So, oh, sorry, there's a field called is running. So is running is true if the watch is already running. Right? So in other words, if someone's already pressed stop, right? Start, sorry, if someone's already pressed start. It's false if the watch is not running. So someone has pressed stop or they haven't pressed start yet. Right? So the only thing you have to do to start a watch is, well, sorry, I guess you should check, is the watch not running? Right? So if the watch isn't running, there's something to do. Right? So if the watch isn't running, we're going to set the start time. Right? So the start time we're going to get from this method called nano time. And then we're going to set this is running to true. Right? If the watch is already running, we're just going to ignore the fact that they press start again. Okay, so when you stop the watch, right, our stop method is going to return the amount of time in seconds since the watch was started. Right? If the stopwatch is already stopped, then the elapsed time in seconds is, okay, that's fine. Right? All right. So if the watch is running, right, and you press stop, right, now is when we have to set the stop time. Right? So your stop time is now equal to the current time, right, which we get again from nano time. Right? And then we set is running to false. Right? And now we're supposed to return how much time has elapsed since the person pressed between start and stop. Right? And so we're going to call our third method that's called elapsed. So our elapsed method, this is the method that returns how much time has passed, either since the person pressed start, right? They haven't pressed stop yet, so we want to tell them how much time has passed. Oops, sorry. Who is this? Okay. Sorry. So if they haven't pressed stop yet, we want to tell them how much time has elapsed since they pressed start. If they have pressed stop, then we want to tell them how much time has elapsed, right? Between start and stop. Okay, so the way I'm going to do this is I'm going to get the current time. Right? So that's just, again, we're going to ask nano time for the current time. Right? If the watch isn't running, right? So if the watch isn't running, then they've already pressed stop, right? Which means there's a stop time and a start time. So we're just going to set the current time to the stop time. Right? And now I'm just going to compute the amount of time between the current time and the start time. Right? And then divide by 1 billion because the start time, those times are in nanoseconds. Right? So to convert to seconds, I have to divide by the value 1 billion. Notice the 0.0 here at the front. Right? So if that 0.0 is not here, right, then what you end up with is current time minus the start time divided by 1 billion. Right? The type of current time, the type of current time is long, right? The type of start time is long, right? The type of billion is also long, right? So you've got 3 ints, right? Integer value minus an integer value divided by an integer value, right? So you have to remember what this means in Java, right? I've got an integer value minus an integer value, right? Their types are both long. Right? Java says if you do an arithmetic operation with 2 long types, you get back a long value. Right? So current time minus start time, that's a long value. Right? Now you divide by another long value. Right? So you've got an integer value divided by an integer value. Right? Java uses integer division here. It doesn't use floating point division. Right? So you're going to end up with the wrong answer here. Well, you're going to end up with the answer that you don't want. It's not the wrong answer. It's just going to be the answer computed using integer division. Right? So it discards everything after the decimal point, which is not what you want in this case. Right? So in other words, so I have to force this operation to be computed as a double or a float. Right? The easiest way to force this to be computed as a double is to stick a double number at the front. Right? So if I put a 0.0 up here, that's a double. Right? Now that's a double plus a long. Right? Java says, well, I've got two mixed types. I'm going to convert it to the wider type. Right? Double is wider than long, so it converts that to a double. Right? Now you've got a double minus a long, so the result is a double. Now you've got a double divided by a long. Again, the result is a double. Right? And you get the correct floating point answer in this case. Right? This is one of the things that you don't have to deal with in Python, because Python automatically, when you divide two integers, it automatically computes a floating point value for you. Right? Languages like Java, C, C++, C#, they don't do that for you. Right? You have to do it yourself. Yes? No, it depends. It depends on the context, right? So sometimes you really want to do long division, right? So for example, if you're computing, if you're trying to compute how much change you're making, right? You've got some number of cents, right? You want to compute change, you're going to end up using integer division, right? So if I want to know the number of quarters in, say, 98 cents, right? I'm going to do 98 divided by 25 as integer, right? Because that's going to give me 2, right? Sorry, that's going to give me 3, not 4, right? It's going to give me 3, not 3 point something, right? So sometimes you really want integer division. Right? It depends on the context. If you're doing division, though, right, and you want the final answer to be as a floating point, then the answer is probably yes. You probably have to coerce something to be a double, right? Which incidentally was another quiz question. But anyway. Okay. Any questions about the methods that we implemented? You can put in a two-string method for stopwatch as well if you wanted to, right? I'm not showing it to you here on the slides, but you can make one up and create a two-string method for stopwatch. All right. Okay. More constructors. So far, we've only got one constructor, right? We have the no argument constructor. So you can have as many constructors as you like in your class. The signatures of the constructors must be unique. Right, now remember what the signature of a method is. It's the name of the method followed by the types of the parameters. Right? It's the same thing for a constructor. Right? So the signature of a constructor is the name of the constructor plus the signature of the types in its parameter list. Right? So the signatures must be unique. Right? In other words, the constructors all have to have a unique list of parameter types, right? Because all constructors have the same name. So for our point2 class, it would be useful if someone could make a point and specify the x and y coordinates when they make the point. Right? So in other words, it would be useful if they had a constructor that took in two double values, x and y, that are the coordinates of the point to be created. Right? Now, this one's a bit funny. Right? I've got a constructor here. It's got a parameter called x. It's got a parameter called y. Right? There's also a field called x, and there's also a field called y. Right? So inside this constructor, right, the name x means the parameter x, and the name y means the parameter y. Okay? If we go back and look at another constructor, say stopwatch, right? So stopwatch, there's no parameter list here, right? So instead of writing this dot raw start time, I can just write raw start time, right? And the compiler automatically sticks this in front of it for you, right? So inside of a constructor, if you use a field name, then inside the constructor, it's the field name that's used as long as there's no parameter that has the same name as the field, right? In this example here, right, you've got a parameter and a field with the same name. So inside this constructor, the name x refers to the parameter x. The name y refers to the parameter y, right? So in this particular example, you must write this x equals x, right? And you must write this y equals y in order to set the fields x and y, right? You can't just write x equals x. That doesn't do anything in Java or any other programming language, right? Similarly, you can't just write y equals y. So here you have to. This is why the keyword this exists. This is why the keyword this exists in the language, right? Sometimes you have to disambiguate between the field name and a parameter name. Right? So when you have a parameter name that matches a field name, we say that the parameter. Somewhere I tell you this. We say that the parameter shadows hides. Somewhere I tell you what is shadows the field. Right? In other words, the parameter name takes precedence over the field name inside of a method or constructor. Right? Whatever you do here, do not write x equals this dot x, right? And do not write y equals this dot y, right? X equals this dot x means change the parameter value to whatever this dot x is. In this case, it's going to set it to 0, and it's not going to do anything to your field x, right? So make sure that you write it this dot x equals x if you want to assign to the field x. This turns out to be very common in Java, where you have a constructor where the parameter names are the same as the field names, right? So this is not uncommon in a language like Java. Okay, so what happens when you call this constructor, right? So when you write .2p equals new .2 blah, 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 right? That line of code causes a variable p to appear in memory, right? So your reference variable p gets created somewhere in memory. Doesn't matter where, as long as it's empty, right? Remember what new does. New allocates memory for our .2 object. So somewhere in memory, our .2 object appears, right? When that object appears, it's just a copy of the class, right? So whatever fields the class has, this object now has, right? So our .2 object has an x and a y field, right? The .2 constructor gets called, right? So new makes the object. The constructor, right, it runs somewhere in memory, right? When that constructor runs, its values, its parameter values its parameter values x and y get set to -1 and 1.5, right? So our constructor has a parameter x, right? It's got a parameter y. X gets set to -1, y gets set to 1.5. Our constructor also has a hidden parameter called this, right? The value of this is the address of the object that's being initialized, right? So the value of this, in this case, is the address 600, right, which is right there. Right? Now what happens? Okay, so all our constructor does is it says this dot x equals x, right? So this dot x, so this is, right? This object at address 600, so this dot x is that x, right? This dot y is that y, right? X is that x, and y is that y, right? So this dot x equals -1 causes that to happen, and this dot y equals 1.5 causes that to happen. Right? And now, the constructor finishes running, right? And new returns the address of the newly constructed object and stores that in P. Right? All right. Any questions about what's going on when you call a constructor? Okay. So in that constructor, you've got parameters whose names are the same as the fields. When that occurs, we say that the parameter has precedence over the field, and in Java you say that the parameter shadows the field, right? It hides the field name. Right? If shadowing occurs, then you have to use this in order to get to the field, right? Which is why which is one of the main reasons the keyword exists in the language. Okay, so why do you want to add this constructor? Because it makes your class easier to use, right? So before, in that little print point example, right, I had to make a point using the no-argument constructor, then I had to call a method to set its coordinates, then I can print the point, right? Now, I can just make the point and set its coordinates all in one constructor call, right? It's much more pleasant to use this class than it is to use the older version of the class, right, where you have to call a separate method to get something done. Okay, there's another important type of constructor in Java called the copy constructor. So a copy constructor is a constructor that copies another object, right? So you've seen the array list copy constructor where you can copy another list, right? A copy constructor for the .2 class would just copy another .2 object, right? And it would initialize the new .2 object to have the same coordinates as the copied point. Right? So your copy constructors, you can always identify them because it has one parameter, right? The type of the parameter is the same as the type of the class, right? So our .2 copy constructor, right, always takes in another .2 object to copy, right? So this constructor is going to copy the other object, right? The type of the other object is .2, right? Now, you've got an object called other, right? Its type is point2, right? We're inside the point2 class at this point in time, right? So inside the point2 class, I can go into the fields of the other object directly, right? So in other words, I have access to the private fields of any point2 object inside the point2 class, right? So to get the x coordinate of the other point, I can write other.x, right? And to get the y coordinate of the other point, I can write other.y, right? I don't have to call the method named x, and I don't have to call the method named y, right? And so the copy constructors, they often look something like this, right? All of the fields of your object, you're just going to copy the fields from the other object, right? So this x equals other x, this y equals other y. If you had a field called z, this z equals other z, right? And so on and so on and so forth. Right? It gets a little bit more complicated when the fields are reference types. But for now, everything's primitive, so we don't have to worry about that. Right? Okay, now why do you want to add a copy constructor? Again, because it makes your class easier to use. Right? So here I can make a point, right, using our second constructor, right, and set its coordinates to -1 and 1.5. Right? Now, if I decide that I need another point that has the same coordinates, I can just copy that point using the copy constructor. Right? So I get a second point, has the same coordinates as p, right, but they're independent points. Right? So if I modify one or the other, right, then the other point does not change. Right? So here we're going to print out the point p. So we're going to get -1 and 1.5. We're going to copy p and then print out the string point q. So we're going to get -1 and 1.5. I'm then going to change the coordinates of p, right, and print out p. So p changes, right? P is now at the point 99 and 44, right? But notice q doesn't change, right? So q is a brand new independent point from p, right? Originally it was a copy of p, but now I can change p or q and not have the other point change, which is the whole point of making objects, right? You want individual objects to have their own state so that you can modify the points, you can modify the objects and not have other objects change at the same time. Okay. Now, if we go back and look at our constructors, right? So look at this constructor here, right? The two lines are this x equals something, this y equals something, right? Oh, in our second constructor, the two lines are this x equals something and this y equals something, right? In the no argument constructor, the two lines are this x equals 0 and this y equals 0, right? In other words, all of the constructors are doing more or less the same thing, right? They all have two lines of code, right? They all just set the x and y coordinates of the point, right? So in other words, what's happening here is we're basically duplicating a bunch of code, right? All three constructors are essentially just setting the x and y coordinates of the point. So wouldn't it be nice if I could write one constructor that sets the x and y coordinates of the point and then have all the other constructors call that other constructor? And so the answer is yes, you can in fact do that. Right? So a constructor is allowed to call another constructor in the same class. Right? So constructor is allowed to call another constructor in the same class. Right? When you do this, it's called constructor chaining, right? Because a constructor calls another constructor. That second constructor can actually call a third constructor. And that third constructor can call a fourth constructor, and so on and so on and so forth. Right? Now, to do this, you need a special syntax. And unfortunately, the syntax that Java chose to use is to reuse the keyword this, right? Which is annoying, but that's the way they decided to do it. Right? So if you want to call another constructor from inside a constructor, right, you don't write the name of the class, you write the keyword this. When you do this, it has to happen on the first line of a constructor, right? So you can call another constructor from within a constructor, but it has to happen on the first line. Right? So what does this look like? All right, so there's our no argument constructor, right? Originally, it was this x equals 0, this y equals 0, right? Instead, I can use constructor chaining to call the second constructor. Right? So our second constructor lets you pick the x and y values. Right? So I can call the second constructor by writing this and then 0 and 0. Right? So what happens on this line is that this constructor actually runs. Right? And it gets the values 0 and 0. Right? So it sets this x to 0 and it sets this y to 0. Right? The copy constructor, right, I can play the same trick. Right? I can call the second constructor, right, this time passing in the x coordinate of the other point and the y coordinate of the other point. Right? So I write this, right, round bracket, other x, other y. That calls this constructor. This constructor sets this x to other x, and it sets this y to other y. Right? And so there, that lets you save a whole 2 lines of code. Right? I don't have to write this x equals y, this x equals 0, this y equals 0. Right? And I don't have to write this x equals other x and this y equals other y. Right? So here I can save a small amount of code and reuse the third constructor. Right? This example here is mostly for illustration purposes. In a class that has lots of fields, constructor chaining becomes very useful, right? Because you might have many constructors that are all basically doing the same thing, and then you're going to have many, many, many lines of duplicated code. If you've got one constructor that sets all of the fields of the object to some specified values, right, that's when it makes sense to use constructor chaining. Right? Here, like I said, you only save 2 lines of code. It's not really that big a deal. Right? Now, the advantages of doing this are, number 1, you stop a lot of code duplication. Number 2, I really only have to test this constructor. Right? So I can test this constructor. When I'm confident this constructor is working, it's almost certainly the case that this one is correct, and it's almost certainly the case that this one is correct. Right? You have to spend much less effort testing the other 2 constructors in this case. Right? Similarly, when it goes to debugging or maintaining your code, right, you really only have to look at one constructor. Right? So if later on someone tells you that there's a mistake in your code, right, and it's in one of the constructors, then you can just look at the common constructor, right, debug it, and then all of your other constructors get fixed for free. Right? All right. So again, the syntax is funny, right? It's the keyword this to invoke another constructor inside the same class. Right? Similarly down here. When you do this, it has to be on the first line of the constructor. The compiler won't let you do this anywhere else. Right? So in other words, if you try to insert a line of code right here, right, then the compiler will fail to compile your program when it encounters this blah, 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 blah. Right? All of this stuff I'm telling you now becomes a lot more important in a few weeks. Because in a few weeks I'm going to tell you you have to call a constructor on the first line of your constructors. But we're not there yet. Okay. So the counter class, I mean, if you want to add more constructors to the counter class, go ahead and add more counters to the constructor class. Right? So maybe we want to, instead of initializing the counter at 0, maybe we want to let the user initialize the counter at some other value, right? Some other positive value. Right? Similarly, it might be useful to copy another counter, so we can add a copy constructor. Right? Again, you can use constructor chaining to minimize code duplication if you want. Right? So our no argument constructor, I'm going to change it so that it uses constructor chaining. Right? So it's going to call our second constructor, passing in the value 0. Our second constructor, this is the constructor that takes in a specified value, right? And it's going to set the counter to that value. As long as it's not less than 0, because our counter can't count below 0. Right? So here we check, is the value less than 0? If it's not, we throw an exception. Right? Exception gets thrown, the constructor stops running, and the object in this case is not successfully initialized. Right? Otherwise, you just set this value to that value. Right? So as long as the specified value is not negative, we can just set this value to that value, and away you go. Right? Copy constructor, well, if I have that second constructor already written, the copy constructor is easy to write. Right? I just pass in the value of the other counter, and away we go. Right? So this example actually shows you one of the disadvantages to constructor chaining. Right? So notice that the constructor that does all the work, it always has to validate the incoming value. right? Because a counter can't have a negative value, right? So here, we're always running this if statement and possibly throwing an exception, right? The no argument constructor just sets the value of the counter to 0, right? So this constructor should never fail, right? Or in other words, this constructor call right here should never fail, right? Because the value is 0. Even though we know that the value is valid, right, this second constructor is still going to recheck that value anyway, right? So you're paying for this validation when you don't have to do it, right? Similarly here, I've got another counter, right? If I've done everything correctly, the value of that other counter is not negative, right? Assuming the rest of my class is correct, right? So again, that other value, that's always a valid counter value. I shouldn't have to check it. However, because I'm using constructor chaining, I'm always paying the price of this validation, right? So there's a small disadvantage in this case in that you're doing some unnecessary work. Right. Oh, okay. There is another lecture. Let's see, is it worth? So I got less than 10 minutes. Okay. Well, let's get started quickly, and then we'll cover a few slides, and then we'll call it quits. All right, documenting. So I haven't told you how to document a Java class yet. From what I've seen, you don't really know how to document a Python class, a Python function, a Python program in a standard way, right? So one of the things with Python is there is no standard way to document a program. Right? There's no agreed upon universal way to document your functions or to document your classes or to document anything else, right? In Java, there is an agreed upon standard way of documenting your classes and your methods and everything else, right? So Java is it's the only language that I know of where the documentation format is standardized, right? So documenting code, this has never been a new idea, right? Ever since people started writing code many, many, many years ago, people realized you have to explain what's going on in your code, right? The way it used to be is that you would produce a separate document that would document your code, right? So you get some code, and then you'd get a bunch of binders that contain the printed documentation for your code, right? So Java came along and it said, hey, this is dumb. We're going to embed the documentation in the source code, and then we're going to write a tool to extract the documentation to produce your documents for you. Right? So Java was the first major language that I know of that embedded the documentation into the code and extracted the documentation into readable documents. Right? The tool that does that is this tool called Javadoc. Right? So Javadoc processes what are called doc comments. Right? So all the source code that I've been giving you, you'll notice that there's a whole whack of documentation in there. It's all Javadoc documentation. Right? So a Javadoc comment starts with /**, and it ends with */*, right? So /* is the multi-line Java comment, right? You put an extra star in, and then Javadoc recognizes that as a Javadoc comment. Your comments can use HTML if you want. So if you don't know what HTML is, don't worry about it, right? You don't have to use it in this course. If you do know what HTML is, then you can use a subset of HTML in your documentation. Okay, so every documentation comment is made up of two main parts, right? There's some description, right? So the description is the description of the method, the description of a class, the description of a field, right? It can be as long as you want, right? And then there are a bunch of what are called block tags, right? So when you're looking at the documentation in the code that you've been given, you'll see things like @param or @return or @throws, right? So @param tells you what a parameter is for, right? @return tells you what the return value is. @throws tells you what exceptions are thrown, right? So Javadoc can recognize these tags, and it can produce the appropriate documentation for them, right? Whenever you create a class or a method or whatever else, you should document it, right? Especially if that class is meant to be used or read by somebody else, right? So every class should have a Javadoc comment that describes the purpose of the class, right? So our little point2 class, Well, it's just a two-dimensional point, right? There's not really a whole lot you want to say about this. So, but you should have a little java.doc comment there that tells people what is this class meant to be used for, right? So we put a java.doc comment at the top of our point2 class and tell people that our point2 class is a Cartesian point in 2 dimensions having real coordinates, right? If you wanted to, and if you were producing professional quality code, you would expand on this description, right? You'd say something about what this class lets you do, right? So you can get the coordinates, you can set the coordinates, right? And things like that. You would tell people what limitations your class has, et cetera, et cetera, et cetera. Right? You can document a field if you want to, right? Or fields, right? So here I've got a java.doc comment that documents these two fields, right? So /**, right? And then so x and y, those are just the coordinates of a given point. Right? If you run the java.doc tool on this class, right? That's all that's in there. Right? So if you run the java.doc tool on that class, you get this page here, right? So you get a web page that tells you this is the class point2, right? It tells you some extra information up here, it tells you the package that the class is defined in, right? It tells you the name of the class. It tells you it extends the class object, which is not meaningful to us right now, right? And you see that line there, right? That's the description from here, right? If you had more description here, it would appear here as well, right? And then you get the rest of the documentation for the class, right? Here there's no constructor summary because here there's no method or constructor descriptions because there are no constructors or methods yet, right? What time is it? All right, so that's a good place to stop, and then I'll show you how to document your methods and constructors in the next class.